Good morning. So you are a little bit into your design challenge. You've made some working windmills. I know you're going to still want to tweak. How many of you feel like you have the winning design? Okay, you feel pretty confident? All right, so we're still going to tweak it, but today I'm going to give you some information to help you out with your lab report because I think it's still a little bit vague what you are going to be expected to do. Last time we did a research project, we did the PowerPoint, and it's going to be kind of the same, but when you're doing a PowerPoint slide, it's bulleted points just a little bit, and you're going to give the information. Well, this time, all the information you're giving has to be written down. So we're going to look at some lab reports, but more importantly, some of your computer-generated graphs in Sheets last time were really good, but they weren't quite what you wanted. And Sheets is not as intuitive as Excel. I get that, so I'm going to help you guys out today. You all should have your Chromebook so that you can physically do the keystrokes and dig in and see how to make those graphs. It won't be your real data, but that's okay. You can just replace your real data into the cells. We're going to do like a practice with everybody's today. I don't want to give too much of a reveal, so if you want to do your least good one, that's fine or whatever, okay? So the first thing that you're going to have in your paper, and I published the rubric online. So let's pull that up really quick so we can see the sections. If you go to the Google Classroom, you should see information that says rubric. Anybody see it? Okay, pull that up. And let's take a look at those sections. Should be under your classwork. Wind turbine design challenge, lab reports, rubric. Okay. Let me toss this over to here so we can look at it. So section 1 is going to be the same as your section 1 last time. It's going to be your introduction. But instead of you telling us about it, you're going to write about it. So you're going to need some background information. Where do we use wind turbines? And I want it to be accurate and relevant and new. So you need to talk about the turbines that we have going on right now, not like people using windmills in Denmark in the 1700s. I don't need like the history of all windmills ever. I need what's going on right now as it pertains to this chapter with wind energy, alternative energy, okay? So this is the best. Obviously, you want to be in this column. So your background information is researched and cited. Your hypothesis is stated in an if-then format and explained. How many of you have a hypothesis? You didn't make a hypothesis?
No, I think we did.
You think we did? Okay. Well, no. You don't have to like spout it off, but you made a hypothesis. Okay. Woo! Okay. Yes.
So we're supposed to have two hypotheses.
Yes, you are. You're supposed to have a hypothesis for your experiment 1 and your hypothesis for experiment 2, and they should be separate. And you didn't have to form your hypothesis for experiment 2 until you started it because it would have been based on your experiment 1, right? How we talked about you're taking the best design from experiment 1 and putting it into experiment 2. So your hypothesis should be in this section. There is no length guideline, okay? Just say what you need to say. It needs to be as long as it needs to be to get your introduction to say all of those things. Yes? Are we pretty clear on what the introduction? Yeah. Now, don't put data in your introduction. When you start writing this, if you haven't done it already, you're probably going to have some data. And that shouldn't go in there. Keep it for the next section. Okay, second section is going to be your materials and methods. Please do not give me a list of materials. Okay? Add your materials into your sentences. It should be in the narrative form. I have many, many science magazines over here. You can grab literally any one of these and see how to write a good materials and methods section. It's fairly brief, but very detailed. It's technical writing. You guys have been working on this in English a little bit, technical writing. So just get to the point. There is zero fluff. Very few adjectives. Very, very, very few. Never mind. See what I did there? Okay. Materials and methods amounts are identified. Steps are easy to follow. Ask someone else to read it that didn't do your experiment. If they couldn't repeat it from your materials and methods, it's not detailed enough. Follow me? Now, you don't have to say the same thing again and again if you did the same thing again and again. You don't have to say, I went back and put it in the fan and blah, blah, blah 4 times. You say, I repeated those steps 4 times or whatever, okay? Then your data. So this is what we're going to talk about today. Third section should be data. Sometimes this section is called results, and that's fine. You can call it whatever you want. Data is complete and relevant. Tables are easy to read, and units are provided. Graphs are labeled and show the trends, and the questions are answered completely and correctly. So how many of you feel about 50% confident with your graphing in sheets? How many of you feel 100% confident? No? You feel 100% confident. Okay, maybe you might be in charge of these graphs. Okay, so this is what we're going to go through today. We're going to take some data, we're going to put it in a spreadsheet, and then we're going to graph it. Okay? I'm going to share this spreadsheet with you right now so that you can write in it. So while I'm sharing the spreadsheet, so we don't waste a lot of time, I want you guys to go pick whatever design you want and go test it on fan 1, fan 2, fan 3, take a reading, and you guys go right behind them. Fan 1, fan 2, fan 3, take a reading, and then when they're done, don't crowd, just wait. Then you guys take your best design, fan 1, 2, 3, and then you take your best design. And then I'll call for those data, and then we will put them in the spreadsheet. Okay? So this should go pretty quick. Just plug it in, plug it in. You guys know how to work the machines. Okay, go. And I'm going to share this data with you. Remember to take your highest measurement, line up your wind turbine, and then watch it for about 10 seconds. Not forever, because we all have to collect data. Okay. Will you guys test for me? See if this is in the classroom. So pull up, it says wind turbine design challenge, and then see what your permissions are. Nope, I just put it, it says practice data, and it's a spreadsheet. And I want you to be able to edit it. So let me make sure that that happened. Oh, no, I'll fix it right here. Refresh it. Try it now. Oh, wait a minute. I gotta save. Okay. Josh, refresh your page and see if it says can edit. Yay! Okay. How's it looking? Is that your best design? It went the other day? Okay, let's see. Do we have this hooked up? There we go. You just need to move it a little bit. Ooh, this guy's a little, he's a little floppy. Do you have another design?
Yeah, it's like the same. Worse than that.
Oh.
Because we had different materials.
That's okay. We've got time to tweak. It's all right. We'll just have 3 windmills today. No big deal. All right, how's it going here? All right, you guys come up and get in line with what you think is your best design.
We just have to do one.
You just have to do one. You can set it a little. Uh-oh. Here, hold on.
Is homegirl okay?
Well, it's okay. Sometimes you gotta engineer a little bit. There we go. Let me see.
I think on band 3 it was I saw 4 here. Is it 4? It's not.
There should be a ha ha ha. Let me get past you real quick. Is it working?
Yeah, it just
4, 6.
Look, this is the answer to all engineering problems. Hold on. You've got, hold this real quick, please. Sometimes these little spindles get rusty. And that's the only piece that they don't really let you replace.
That's a fun word.
Spindle. That makes me think of Sleeping Beauty.
You're dumb.
9-5, 9-7.
Thanks for coming with me.
Spindle. Spindle.
Okay, watch out.
Spindle.
Here we go. Yes. Yeah, absolutely. Let me first make sure it's not jammed in there too, because sometimes when the parts are so close together, you really build up a lot of friction. And then, there we go. Give it just a little bit of space.
7, 7.
Oops. Okay. Ooh, now we should be in business. All right, try it.
I think 8, 6.
And then you can give it a little,
I think we should have put some.
pull it toward you, the whole thing. There we go. Okay. All right, is everybody getting good reading? That one's pretty good. All right, where are you recording this? Good, good. No, not in your head. Never in your head.
So these are producing energy.
They are, yes.
They are. Okay.
They are
I'm just
producing
making sure
energy.
for our hypothesis.
They are generating energy.
generating. Thank you.
They're transforming energy from wind to electric energy.
Okay.
This is performing an energy transformation.
I was going to ask you if you stay after school or we have to come back.
Not typically, but I'm here during break and in the mornings. Let me think about what days this week I can. Just depends on when the kids have stuff. All right, you got a data? A data. You have some data? Do you have a data? Actually, data is plural. These data is correct to say. Ready? Who else needs to test? Yeah, you have to do it on all of them. Fan 1 is open. Woo! Woo, woo. And remember, that's the lowest fan speed, so the lowest wind speed. You've already done one? Okay.
That's fan 3.
No, this is fan 1. It says it.
It's been fan 1 the whole time.
I wrote it down right the first time.
I wrote it down as fan 3.
Grab that 40. Can you grab the 40?
Here, do you need to see?
Can we
All right.
try that one again?
Yeah, go ahead.
That one and that one were the same. And I don't think that's
Okay, go ahead. Try it again. This one's empty. All right, so you're done with that one? 2.02, nice. Yeah, breaking 2, I think, is the holy grail. That's where you're going to get those Twizzlers. And you guys need to do this one? Oh, you're already doing it. Okay.
Like, there's an inner to the right.
How is it not connected?
That's fine. All right, don't forget this is just practice. It doesn't have to be perfect. You just want to get a reading so that we can generate that graph. That's fine. I would expect it to be pretty low because this is the lowest wind speed.
It's not 4 or 5.
It's not 4, 7.
I say take it. Oh, 4.8. I saw 4.8. And nobody needs fan 2 right now? You just need fan 1? And you need fan 2? Still? Okay. All right, that's good. Come on. You just keep thinking if you just leave it longer, it'll spin faster.
We're just looking for numbers.
I got it. That's right. We're just looking for numbers. Uh-oh. Here, let me turn it off and turn it back on.
That one, it was slipping off the
Okay, go.
back earlier.
Oh yeah, it's not spinning the bottom. This one is kind of rusty. Ah. I had to do surgery on this one the other day. It's not my favorite. Okay, it's spinning now. Stay on there.
Isn't this the fastest fan?
It is the fastest fan, and I just really need to fix this windmill.
I feel like if my other one broke too.
Ooh, I saw. Ooh. Dang. Yeah, 2.05. Okay, we good? Is that your last one? Okay, let's graph. So everyone at this point should have access to the spreadsheet, and you should be able to edit it, even though right now I am going to be editing it because I just want to show you how to do it. Okay? So these changes should show up in your spreadsheet that you have. And in addition, there's a tab at the bottom that says Sheet 1 that already has a graph on it. So we're not going to look at that one just yet. So right here, I'm going to put in column B, I'm going to put Design A, and that'll be Table 1. And then I'm going to put Design B, and that'll be Table 2. Nope, Table 3. And then I'm going to put Design C, and that'll be Table 5. We only have 3 that we tested, right, today? Oh, you have 1. Okay, let's do Design D. Okay. Now, for you guys, this would be blade shape A, and you can just call it something very technical, like blade shape 1, blade shape 2. If you want to give it a name, paddle shape, rectangle, it's your experiment. So as long as you're putting down something that is descriptive enough to you that when you look at it, you're going to know, okay, this is the design. The other thing is, and listen, what you put in the spreadsheet appears on your graph, unless you change the legend or change the title or whatever. So if you're showing this to people, in this case the people is me, but in real science the people is everybody, you want it to make sense. So sometimes blade shape 1 is not very descriptive. You might want to say blade shape 1 paddle, or then have, along with your paper, a diagram that shows what blade shape 1 looks like. And so those would be things that you would digitally add. Do you guys know how to use the drawing tool in Google Docs?
Yeah.
Just go insert drawing, and then you can freehand draw whatever your shape looked like. Okay? So I would highly suggest make sure your description is as detailed as possible. Okay, so down here, I'm in column A, I'm going to put trial 1, and that's going to be fan 1, trial 2, and then I'm going to put trial 3. Okay? What's the next thing that why are you taking away? Who did that?
I didn't do that.
Come on, guys. Okay. Design A will be you guys. You ready? Table 1. What did you get for trial 1? 0.94.
Trial 1 is fan 1.
Yes. 0.94. Okay, what'd you get for trial 2? 0.87. And trial 3? 0.48. Ooh, that one went way down. That's okay. All right. Design B. We'll say this is Bailey's. What'd you get? Yep. 0.8? 0.08? Okay.
And then point 38
Okay.
and 0.93.
Okay. Oops. No, it's okay. That's actually really good because I have something to show you with this graph. Okay, design C. Hey, Liliana.
Oh, hold on. We flip 1 and 3.
Okay, so 0.93
Yes.
and then 0.08.
Yes. So sorry.
Not a problem, not a problem. And you guys should make sure that what you're putting in your spreadsheet really reflects what is on your data notebook. Check it again. Okay, Mia, what'd you get for first fan?
2.05.
Second fan?
2.02.
Third fan?
0.95.
Okay. And then guys in the back, what'd you get for the first fan?
1.10.
Okay, second fan?
0.49.
Okay.
0.88.
Got it, perfect. Okay. What do we need to do to these 3 trials? We need to average them. Watch how you put an average in both Excel and Google Sheets. Go to the cell. I'm going to put average here so I know what this row is. Then you're going to go to the cell that you want the average in. Yes, ma'am.
It says 2 and 3.
Okay. So 0.88 and then 0.49? Whoops. Got it. Okay, so you're going to go to the cell where you want the average. Just lay that on the front desk. Thank you. Just tell her I'll send her one. All right, and then you're going to put, are you looking at me? Are you paying attention? Because if you've missed this step, nothing's going to happen. If you want to put a formula in a cell, what is the first thing that you put? Equals. Okay, so you're going to put equals. And then you're going to put, what do you guys think?
Average.
It's average. Yeah. So sometimes these are meant to be intuitive. You shouldn't have to like really struggle to figure out how to do the average. You can look it up. And these spreadsheets have where they think they know what you want to put. See, it's suggesting to me average. Oh, yes, good suggestion. I do like that. So sometimes it'll suggest for you what it thinks you want to do, and it happens to be correct. In this case, I do want to put the average. So I'm going to put the average, then open parentheses, and I'm going to select the cells I want to average, and then I'm just going to put return. Now see how there's a million decimal places? That's no good. Okay, so these 2 buttons up here, look on yours or look on mine, they decrease and increase your decimal. Remember our significant figures? That's really important. You can't just leave whatever decimal places you want. If that voltmeter only measures to the hundreds place, you cannot report your average to the thousands place. That's fake news. That's just data that's made up. You can't have possibly known it to the thousandth place. You follow me? So you have to get your digits under control. Then watch this. You don't have to do it a million times. We already know that we want the average in this cell, so I'm going to go to this little square in the bottom right corner and just pull it over. And it intuitively knows I want the average for all of these. Then I'm going to get my digits under control because I can only have the hundreds place. Okay? Not the thousands place. Ta-da! Okay, now we're going to do something kind of intense. We want error bars on our graphs. Now, a couple of you put error bars on your graphs before, but you didn't really know why or where they came from or what you were doing. So let's fix that, okay? Error bars show the spread of your data. So I'm glad you had this crazy one because now we can talk about it. This trial was very different than the other trials. And I know we were using different fans, but you can see this is an anomaly, right? So this error bar is going to be much taller because the spread of this data or the variation in this data is much more than the variation in, say, this set of data or this set of data. So it shows your variation. I know we've had an example like this before, but you can have 2 sets of data with an average that is the same. Let's say you have a 10 and a 0. What's the average? 5. And let's say you have a 5 and a 5. What's the average? 5. Are those 2 sets of data the same? So if you just report the average on your graph, you're missing a lot of information. You're saying, oh, they were the same. They were totally the same. That's not the case. So you need to show the spread of your data. And even though you're only going to graph the average as the bar, these error bars are very easy to put in, and they give you a lot of information. So how do you do it? you need to have the standard deviation. So I'm going to write this, but I want you to see how it's done, and this is shared with you so you always have it. So you're going to go down and write standard deviation in this cell, and then over here, the key for standard deviation is STDEV. So it's just an abbreviation, and it's exactly the same as average. You're just going to highlight the cells you want to do the standard deviation of. Make sure you don't grab your average, right? Because that's not part of your data set. Okay, so just these three. Close parentheses, enter, and then pull it over. Blah, blah. Standard deviation. Now, just right off the bat, this deviation is pretty big. This deviation is pretty big. This one has the smallest standard deviation. You guys see that? So this data is the tightest around the average. Okay? So let's graph it. Exciting. So I'm going to grab row 1, which sounds silly. There's no information in row 1, but there is. Row 1 is our x-axis. Design A, design B, design C, design C, D. So you're going to grab your x-axis and then control row 5. You can multiple select if you hold down the control. Actually, I'm not even sure that that's true. Is that true on a Chromebook? Okay. Sometimes you guys don't have the functions I have. So then you're going to go up to Insert, Chart. Now, it probably will know you want a bar graph, but you can change whatever you want. It tries to help you by guessing the best graph for this data. And is the bar graph the best graph for this data? Somebody want to tell me why? You're comparing. Yep, you're comparing 4 things that are they are similar. Why? Let me ask it this way. How come you wouldn't use a line graph?
There's no continuation between them. You wouldn't have any steps in the middle.
Yay, there's no continuation in between them. They are unique objects. This thing is different and unique from that one. There's no hybrid in-between situation. It's not a continuation. It's not time that keeps going on and on and on. Remember we talked about the raccoon bear? If you're going to compare bears and raccoons, it's bar graph because there's no such thing as a raccoon bear. Okay? So there's no such thing as a in-between of these two things. So it is a bar graph. It knew that. Yay! Okay? And so we're going to look. This is our average. This bar for each one only represents one number, the average. So go over here. This chart editor should already be open, and you're going to go to Customize. Then you're going to go to Series, and you can be jotting down how to do this if you feel like you're not going to remember. And then you're going to pick each series. Column 1 is our first series. So our standard deviation for column 1 is 0.25. Yeah, I'm going to click error bars. Then I'm going to click constant, and I'm going to change it from 10 to 0.25. So I'm just reading off my graph. As soon as you push enter, it applies it. Oh, it's so cute. Look at how cute. They look like little eyes. But look, it's showing us that there's a good amount of deviation here, but that's okay. It's all right, we use 3 different fans. We're going to compare the deviations across them. Okay, I want you guys to put the error bar for bar B. You to put the error bar for bar C. And you guys for bar D. Go ahead. Pick who is going to do it. Do it. Let me see what it looks like. So you go to Series. Pick your series. Don't mess with any other series. Then you're going to hit error bars. Did you get it on there? Josh is doing it?
I am. Mine's not updated with yours.
Sheet 2. Are you on sheet
Yeah, you should be on sheet 2. We had 4 bars.
Oh, God.
You're good.
series and then what?
You should also be on sheet 2. Go to series and choose your series. Oh. Wait a minute. Go to customize. There we go. You have to be under the customize. Okay, now go to series. Then instead of apply to all, right, just pick the one that you're doing. Perfect. And then error bars. Awesome. And then what was your value? You might have to move your graph out of the way. Constant, and then Yep, drag it down. Looks like 0.31.
We're doing it for
Yep, constant. Oh, look, you guys' error bars look so good. Are you seeing them on yours? Okay. All right. So here's the big reveal, the big importance. I know this is kind of low. Can you guys see this? You're looking at yours too. See how, look at me, look at me. See how the error bars for design, well, I don't know how this got messed up, but the red, which is B, overlap with the green. Do you see that? Yes? So this, if you were to follow it over, that means that there were some numbers in this range that were the same or in the range of the numbers for this range. So if you didn't have the error bars, students up until this point in their life would say, green is better. What happens if the green windmill costs 3 times as much to build? Is it really better? I mean, is it that much better? It's really not even statistically better because some of the green readings were not as good as some of the red readings. Do you see the new level of scientific information you're getting here with these error bars? Because up until this point, like if you did science fair in middle school, oh yes, fertilizer B is better. Right, but better in science is based on math. Okay? So is C better? Is C the best windmill scientifically, statistically speaking? It is. The bar is way higher and the error for it does not overlap with any of the other bars. Yeah? So this is by far the design that is statistically the best. It's going to give you the most energy. Now you're still going to have to calculate cost. If it costs $1 million versus $100,000, you might just not be able to build it in the first place. But we're just looking for a design here. We're not paying for it. We're just the engineers. Okay? So how are we feeling about graphing? Can you fill in your numbers? Okay? The last section on the paper, the lab report, is the conclusion. You can call it a discussion, you can call it a conclusion, whatever. It summarizes the experiment, cites data, addresses the hypothesis. Are you going to say the word prove? No. You better not. You better not. We do not prove in science. What do? We support our hypothesis. We support our hypothesis. What happens if we do not support our hypothesis? The word for it is reject. So the data led us to reject our hypothesis, or our hypothesis was not supported by the data, which should automatically just roll you into some further questions. Right? What are we going to do now? Even if your data was supporting your hypothesis, it should still roll you into further questions. That's the coolest thing about science, is it never ends. Each thing you learn makes you think about a new thing that you could ask. So you're going to include that. Sources of error, possibly, and then you're going to include opportunities for new research, new questions, all that stuff. My favorite section is the discussion section. It's the only section that can be a little bit less technical because you can use your creativity as a scientist and think, well, try to explain this might be why this happened or this might be why this happened. You get a little bit of artistic license, which never happens in science except for when you're talking about your research.